particle moves in a straight line such that after t seconds its displacement x meters from the origin is given by s of t is sine pi t. Where is the particle initially? Well, initially, remember, means t equals 0. So s of 0 is just going to be sine of 0, which is 0. So it's actually at the origin. We want the distance travelled by the particle in the first half second. So let's do s of 0.5. So that would be sine of pi times 0.5, or pi by 2, which is equal to 1 meter. So let's just leave it there. I don't think the particle actually turns around in that short space of time, half a second. We could always check for that, of course. You can actually draw the graph of this and then you'd know. The displacement of the particle in t is 2, so s of 2 is going to be sine of 2 pi, which is 0. So displacement is 0 at time equals 2. Now we want the distance travelled by the particle in the first 2 seconds. Now this is where I might refer to a sketch, and of course you can use your calculator to help you get that. So here's a sine graph, and for the standard sine 0, we know that this is pi, this is 2 pi, so this is pi by 2, this is 3 pi by 2, but of course we have sine pi t. So it actually gets here when t is a half. It gets here when t is 1. It gets here when t is 3/2. And it gets here when t is 2. So the distance travelled means that it's going to go from the centre to its extreme, back to the other extreme, and back to here. Well, it's just sine, so this is 1 back to the middle, 1 to here, and 1 to here. So it's travelled a total distance of 4 meters. We now want an expression for the velocity, so we need to differentiate. So sine goes to cos, so that's going to be cos pi t. Use the chain rule, so we multiply by the differential at the inside, so it's going to be pi cos pi t. The initial velocity is then going to be pi cos 0. We know cos of 0 is 1, so that's going to be pi, and that would be in meters per second, since we know that s is in meters and t is in seconds. We want the average velocity over the first half second. So that's going to be the distance travelled divided by the time, and we've already worked out that the distance travelled was 1, the time taken was a half, so that's going to be 2 meters per second. Then we want the initial acceleration of the particle, so we need to differentiate again. Cos goes to negative sine, so it's going to be negative sine pi t. So we already had a pi there, another pi will come out and multiply, so that's going to be pi squared, but a of 0 is just going to be 0.